Okay, now we move to solving problems. Of course, we're going to state the problem and then the solution of each problem. The problem number one, it says a researcher wants to test the claim that the average cost of tuition and fees at a public college is different than $5,000. This is the claim. He selects a random sample of 36 public colleges and finds, of course, the sample mean to be $5,300. The population standard deviation, sigma, is equal to $600. Using the 5-step hypothesis testing procedure, can he conclude that the mean cost of tuition and fees is different than $5,000? Assume that the population is normally distributed and that alpha is equal 0.05. Great. So now we have to go through the steps. The procedure, which consists of 5 steps. First, step number 1, state the null and alternate hypothesis. Remember that here, since, of course, here we have a two-tail test, okay? So the mean, as sub 0, the mean, or the mu, is equal to $5,000, and then the claim, which is the alternate hypothesis, is that mu, or the mean, is different than $5,000. Okay, we have a two-tail test because, as you can see, alternate hypothesis does not state any direction. We have any direction, whether it's greater than or less than. So it is a two-tail test. Great. Now, second is to select the level of significance. It's already set here, which is alpha equals 0.05. Okay, remember, because we have a two-tail test, then this alpha should be divided by 2. And half of this alpha will be in the lower half of the curve, and the other half, of course, of 0.05 will be in the upper half, because we have two-tail tests. So we have to split 0.05, of course, split that one, half of it, which is 0.025, will be in the lower tail, and the other half, 0.025, in the upper tail, as you will see in just a moment. Of course, we're gonna illustrate them graphically in just a moment. So, whenever we have a two-tail test, alpha should be divided by 2, so that half of the alpha is stated in the lower half in the lower tail, and the other half will be located in the upper tail. Okay? Now we select the test statistic. Remember now, since sigma is known, which is equal to $600, then because the standard deviation is known, then we're going to use the Z statistic. So the Z statistics, Z calculated, is calculated using this formula over here. Z equal X bar, the mean of the sample, minus mu, the mean of the population, over the standard deviation of the population, over the radical n, which is n is the sample size. Now all these values are here. We pick them up from the question, and we plug those numbers here. We come up with 3. So the Z calculated is equal to 3. Great. Now we move to step 3. Step 3, we finish this, is equal Z equal 3. Now we move to step 4. Step 4, formulate the decision rule. Of course, to formulate the decision rule, we need to first find the critical value. We need to find the critical value. First of all, as I said, you remember that the appendix, in the appendix, the Z table is based on half of the area under the curve. Z table is based upon half of the area under the curve. Therefore, what we do, since we split 0.05 and we get 0.025, of course, 0.025. So what we do, 0.025 is in the lower tail, and another 0.025 is in the upper tail. So to find the Z critical, to find the critical value, so what we do, we just subtract 0.025 from 0.5, because the Z table in the appendix is based on half of the area under the curve. So we come up with 0.475. So what we do, you just go back to the, kind of simplified version of table, of the Z table in the appendix. I stated that in the discussion of the lesson. You go back there and you see that the value in the Z table, we get a critical value of 1.96. Remember that when we, of course, use the table, remember, so here what we're saying, probability of 1.96, probability of 0 to 1.96 is equal 0.475. Okay? Because as I said, the Z table in the appendix is based on the half of the area under the curve. So we take for probability of Z, probability of Z 1.96 is the same as probability of Z to 1.96, which is Z. Okay? We come up with 0.475. So 0.475, if you look at the body of the table, you will come up with 1.96. So this is the critical value. So what we do now, we draw, the standard normal curve. So we put 1.96. Since we have a two-tail test, then we're going to have, critical value here in the lower tail and another one negative in the upper tail. So this is the critical region. This is the critical region or region of rejection. This is the rejection region and this is the rejection region. So if the Z calculated is inside this, that is greater than 1.96, then what we do, we reject the null hypothesis. If the Z calculated is less than 1.96 or greater than minus 1.96, then we, of course, accept the null hypothesis, or we do not reject the null hypothesis. Now we look at the Z table, we calculate the Z, we look at the Z calculated, we come up with a 3. So now we go to step 5, which says make a decision. So Z calculated statistics is equal to 3. Z calculated 3 greater than Z critical equal 1.96. So it's over here. Okay? So Z over here, which is three. It's greater than 1.96. Therefore, what we do, we of course reject the null hypothesis. We reject the null hypothesis here, and we of course accept the claim that the mean, of course, tuition cost of tuition and fees at a public college is different than $5,000. Now we move to problem 2. Still, we are solving problems regarding the use of the Z table. Of course, problem 2 says last year the average of students attending LIU was the average age of students of students attending LIU was 21.3 years. In order to meet the needs of older students, more classes were scheduled during evening and weekend during this semester. So this semester, of course, the administration of the university opened more classes in order to meet the needs of older students. Has the average age of the students at LIU increased this semester as a result of opening or more classes in the evening and in the weekend? To answer this question, a random sample of 64 students from the university was selected. The average age of the students was 22.1 years. The average age of the students selected, 64 students, was 21.1 years. Given that sigma is equal to 2.7 years, and that it is assumed the population is normally distributed. Why? It is normally distributed because we have a very large sample, over 32. We have 64, individuals in the sample. So it is guaranteed that we have a normally distributed population. Anyway, sigma is 2.7 years, and that it is assumed that the population, it's assumed the population is normally distributed. Choose, of course, choose alpha equals 0.01, the level of significance. Use the 5-step procedure to test the average of students this semester is higher than it was last year. So, and then we have a claim. Therefore, we have a claim here. Solution, of course, step 1, state the null and alternate hypothesis. Of course, we have here a one-tail test. Of course, in the alternate hypothesis, we're going to test, of course, the claim that is mu, or the average mean of ages, is greater than 21.3, and the null hypothesis is that it is less than or equal to 21.3. So as you can see, H1, which is the alternate hypothesis, of course, state direction, which is greater than. Okay, so here we have a one-tail test. Okay, and since we have the inequality greater than, the direction is greater than in the alternate hypothesis, then of course we have the rejection region in the upper tail, because we have two tails. We have upper tail and we have lower tail. Because the direction is, the inequality sign is greater than, then we have the rejection region in the upper tail, to the right of the zero. Of course, the middle, because we have standard normal, so to the right of zero, we're gonna have the rejection region. Now, we move to step 2. Select the level of significance. Of course, it's already given, which is 0.01. Okay? Now, step 3, select the test statistic. Of course, since, of course, the standard normal of the population is given, is known, then we use the Z table. Of course, we use the Z table. The test statistic is Z, of course, and we just plug that in the formula here, plug the given values. We have X bar 22.1, of course, 22.1. This is the average age of students in the sample that was selected, minus the average mean of the population is 21.3, divided by 2.7 over 64, we come up with the value of the Z statistic, is 2.37. Great. Now we move to step 4. Now in step 4, we have to formulate the decision rule. Now, of course, first in this step, we have to calculate the z critical. Now, of course, this critical region is in the upper tail. Therefore, to calculate the z critical, all we have to do, because as you know, that the area underneath the curve is 1. But since the critical region is in the upper half, so we take half, because here we have 0.5. Half of the area under the curve is 0.5, and the other half also 0.5, and both will equal 1. So what we do here, since the critical region is in the upper tail of the curve, then what we do to calculate the critical value, we just subtract 0.01 from 0.5. We subtract 0.01, the level of significance, of course, from 0.5, and we come up with 0.490. Okay, now, how are we going to calculate now the z critical? So what we do, 0.490 is the area between 0 and the critical value. Okay? When you go to the appendix B.1, the z table, of course, look at the body of the value 0.490. You remember, as I said in the previous question, that, of course, this is the value 0.49. So now, as you see, the area to find the value of the z critical, of course, the probability of z equal probability of 0 to the z is going to be equal, of course, 0.490. So therefore here, when you go to the body of the table, of course, the critical value is in the row and the column corresponding to 0.490, which is 2.33. Already I gave a kind of a simplified version of the z table, of course, when I discussed some concepts in the lesson. So you go back and see exactly how we calculated the z critical. Of course, how we calculated the z critical. In the previous question, of course, I did that. So you go back to the previous question and see exactly how the z critical is calculated. So once we calculate 0.490, just go to the body of the table, and then, of course, you locate, of course, along, of course, the column of the z, you find the value, which is 2.3, and then you go to the row to 0.03, you come up with 2.33, which is the value of the critical value that correspond to 0.490. Okay. Now we draw this, curve, normal curve, to show you that, of course, this is the critical region. This is the rejection region, and this is the critical value, 2.33. So this is 2.33 here. Okay, it is the critical value, and this area here is the critical region. Now, we compare this one to the z statistics we calculated. We come up with 2.37. We see that 2.37 is inside this rejection region. 2.37 is greater than the critical value 2.33. Therefore, we reject the null hypothesis and we accept, the claim, that, of course, the population, mean years, the population of the average of the students' ages is, 22.1. Okay? So now we move to step 5. Now, after we have shown that the z value is 2.37 is greater than 2.33, therefore we are in the rejection region. So step 5, make a decision. So the decision is that we accept, we reject the null hypothesis. We reject the null hypothesis because we are in the rejection area, and accept the claim. That is, we accept, that the average age of students this semester is higher than that it was last year, which is 21.3. So now, as based upon the test procedure, we say that we are in the rejection area. So we reject the null hypothesis. We reject the null hypothesis and accept, the claim that, that the average age of students is greater than 21.3. Okay, now we move to problem 3. Problem 3 says, still we are focusing upon using the C table. The first problem we solved, the second, and this is the third, are based upon using the Z table, since the standard deviation in all these problems is known. So here in problem 3, based on studies about the wind patterns over the ocean, a new route is proposed for commercial airlines going from Francisco to Honolulu. The new route is intended to take advantage of existing wind patterns to reduce flying time. Okay, so a new route, the purpose of this new route is to reduce the time of flying. It is known that for the old route, the distribution of flying time for a large 4-engine jet has a mean of 5.25 hours, with sigma equals 0.6 hours. 36 flights on the new route have yielded a mean flying time of 4.9 hours. The question is that, does this indicate that average flying time for the new route is less than 5.25? Use a 5% level of significance. Now, according to the question, as you can see, for the old route, the distribution of flying time for a large 4-engine jet has a mean of 5.25 hours. So now, when we take a sample of 36 flights on the new route, the mean flying time has been reduced to 4.9 hours. Now, the question, the claim is that, does that indicate that the average flying time for the new route is less than 5.25 hours, the average time in the old route? So we have to test this claim, okay? Now, to test this claim, we go through the 5-step procedure. First, we use the 5-step procedure to test the claim. Step 1 state in H0 and H1, the null hypothesis and the alternative hypothesis. Now, our claim is that in the alternative is that the mean time is less than 5.25. So the null hypothesis, the mean time is greater than or equal to 5.25. Okay? Now, remember here that since the direction in the alternative hypothesis points to less than inequality, direction is less than, so this will point to the rejection region, to the location of the rejection region is now where it's in the lower tail of the curve. We have upper tail and we have lower tail. Because it is less than, this points to the location of the rejection region, which is in the lower tail, to the left of 0 in the normal curve. Okay? Now, of course, here we're going to use a normal distribution, because according to the central limit theorem, when you have the sample size is large enough, then the distribution will approximate to normal distribution. So here, then we are going to work with normal distribution. Now we move to step 2. State the level of significance. It's already stated here in the question. It is 0.05, 5%, which is 0.05. Now step 3, select a test statistic. Of course, since the standard deviation is known, then we use, of course, the test statistics that will be used is Z, the Z test. And the formula of the Z is here, as stated here. It is X bar minus mu over sigma over divided by the radical N. Okay, where N is the sample size, sigma is the standard deviation of the population, and X bar is the mean of the sample, and then mu is the mean of the population. All these values, of course, we plug them here in the formula, and we come up with minus 3.5. Okay. Of course, in the Z table we don't have negative because it's a normal distribution, and it is one of the characteristics of a normal distribution is that it is symmetrical. So we take 3.5. Of course, this is minus 3.5. Sorry, this is the value. Now we move to the Z to calculate, the critical value. We move to step 4, formulate the decision rule. Okay, formulate the decision rule. Now look over here. The decision rule is formulated by finding the critical value from the Z table. Since we have a one-tail test, here we have a one-tail test, then, of course, we need to subtract 0.05 from 0.5, okay? So we do that, we come up with 0.45. Now, we locate the value of 0.45 in the body of the table, the body of the Z table in the appendix, okay? We have a simplified version of the table when we discuss the lesson. Just go to the lesson, okay? So we got 0.45. So locate the value of 0.45 in the body of the table, Z table, then read the critical value in the row and column corresponding to 0.45, which is in the body of the table. You come up with the critical value is 1.65. So the critical value is 1.65. Since the rejection region is in the lower tail, then we're going to have, and because we have a normal distribution, and one of the characteristics of the normal distribution is that it is symmetrical, therefore we put minus 1.65, because in the lower, the rejection region is in the lower tail, so it has to be, minus, negative. So because it is minus 1.65, so we put minus 1.65. Now, this is the critical value. Now, and this is the rejection here, the rejection region. Okay, rejection region. Okay, with alpha is equal 0.05. Okay, alpha is equal 0.05. So now we compare this critical value with the test statistic, the Z statistic minus 3.5. So minus 3.5 is here. it is inside the rejection region. Therefore, we reject the null hypothesis. Here in step 5, make a decision. Since minus 3.5 is inside the rejection region, then we reject the null hypothesis, of course, F0, and conclude that the average flying time is less than 5.25.